Okay, so let's do one more example of showing that the function is decreasing. Okay, I'm going to do it two ways. One way is to just do it algebraically, right? Compare an plus 1 with an. So I'm going to just subtract the two, okay, and see if it becomes positive or negative. An plus 1 is n plus 1 squared plus 1. Okay, and an is n over n squared plus 1. So at the bottom you get n squared plus 2n plus 1 plus 1, that's plus 2. Okay. Okay, so we gotta combine that. Okay, so it's n plus 1 times by n squared plus 1 minus n times this. Okay, so let me clean that up. Right, you get n cubed plus n squared, right? And n plus 1 minus n cubed minus 2n squared minus 2n. Okay, same thing at the bottom. So that cancels out. And these two collect to become minus n squared. Those two collect to give you minus n, and there's a plus 1. The same thing at the bottom. So the bottom is strictly positive because n is always positive, and there isn't a single negative sign at the bottom. Okay, at the top we have some negative signs. Okay, so I'm going to complete the square to analyze where this is exactly negative. Okay, so let me factor out a negative 1. You get this. Leave the plus 1 outside. And this is the same thing like n squared plus n. I have to add a 1 over 4. And the outside I have to add a 1 over 4 as well. And you get a minus n plus half squared plus 5 over 4. Okay. And this is a parabola that's clearly, right, beyond negative half and 5 over 4. It's clearly going down. So as n gets, large, right, to infinity, right, an is clearly becoming extremely large negative number. Okay, so this whole thing is definitely it's negative value. Okay, it's negative. Right, the numerator is negative, maybe beyond 2. Okay, I mean I can find out exactly what the x-point is, the x-intercept is, but I'm not even going to bother. You just know that after 2 or 3, it's going to continue to be negative and it'll stay negative. So we have a negative divided by positive, so this whole thing is negative. Okay. So that means, going back up here, this is negative, meaning an plus 1 is less than an. So that means it's decreasing function. Okay, so the second method is, again, treat this as a function and do the derivative. So x over x squared plus 1. Okay, so let me differentiate that. So you get 1 times x squared plus 1 minus x 2x all over x squared plus 1 squared. So you get x squared minus, that's minus x squared plus 1. Okay. So it's the same scenario here. The bottom is always positive. Right? This right here, if you have to draw it as a graph, it's 1 minus x squared. So it's after 1, right? It's always negative. Right? So this is negative when x is greater than or equal greater than 1. Okay. Therefore, f at x is decreasing. So therefore, an is decreasing.